This is going to be a basic video on financial models, what I consider to be plug and chug. First thing I'm going to do is a couple of calculator solving problems. So you're going to want to pause the video here and make sure you have your calculator. Okay, so before I get into financial models, the first thing I want to do is look at a problem such as e to the 2x equals x plus 2. And this is a problem that I'm going to solve using my calculator. So I'm going to go to my y equals, and I happen to have my plot on, so I'm going to turn my plot off from previous problems that I was doing. And you'll see that I have e to the 2x already in my calculator. So pause the video and type in e to the 2x for in your y1 or your y5 or whatever, and then type in y equals x plus 2. Make sure the equations are turned on. So I'm going to make sure I'm going to darken in, and then I'm going to turn off. Actually, I'm just going to clear out some other things I have in here. Okay. So I want to see what this looks like. I'm going to do a zoom 6. And that's e to the 2x. And then x plus 2 is a line. So if I want to solve this, I want to see where the line intersects the curve. So hopefully this is review. Second, trace. Number 5, arrow to the left or the right, doesn't matter. It says first curve, which in my case is e to the 2x, enter. Second curve, which is the line. So my cursor looks like it's on the line, enter. Guess, I'm going to try and get as close to that intersection point as I can. Don't forget to put enter. And then the intersection is at when x is negative 1.98. So I'm just going to move this off to the side. In general, unless you are told otherwise, you should be rounding to the nearest hundredth. I believe in directions. I've always told you what to round to. Do it again. Second trace, 5 for intersect, arrow to the right, enter, second curve. I mean, it looks like I'm pretty close to the intersection point. That's what matters. And then again, to the nearest hundredth, it is 0.45. And you know, technically you should really write your answer in curly brackets. Am I going to take off points for that? No, but that's really how you should show your answer. Okay, let's do another one. Let's do another one. Let's do e to the x minus the natural log of x equals 4. Pause the video, put those equations into your calculator. Okay, so I have that in there already. I'm going to turn off the previous 2 equations. You can delete them if you want. I don't see any need to. You've got 10 options for your y equals. You have 10 options, so why clear all that? Just turn them off and on. Turn them on, turn them on. E to the x minus ln x. I really have no idea what that looks like. And you're not expected to know what that looks like either. Again, I'm going to do a zoom 6. That's e to the x minus ln x. And 4 is a horizontal line. So be careful. It doesn't look like this curve intersects the horizontal line, but you don't know for sure. Second trace, intersect. See on the first curve, it says 0, y equals. Right now, my cursor isn't even on that curve. Oh, but as soon as I arrow to the right, it was. So I'm going to just push enter here for my first curve. My second curve, get close to the point. It almost looks like they're on top of each other. Guess. And they do indeed intersect. So don't be fooled. Make sure you arrow right, left, and try to get close to the intersection point. So in the beginning, didn't look like they intersected, but they do indeed intersect. So this is going to be 0.05. Okay, and then you should try it, see where you get for the next intersection. Arrow over, second trace, intersect, and this is 1.48. Okay, so that's just some review, or maybe it's new, of how to use the calculator. Next, we're going to talk about financial models. And this has like a ridiculous amount of real world applications. So in this video, we're just going to do some plug and chug. You can read about this, you can look it up online, but annual is one time per year. Semi-annual goes 24 times per year. Bi-weekly, be careful, bi-weekly and semi-annual are not the same. Semi-annually means semi-annual is twice per year. Sorry, I don't know what I was thinking. Semi-annual is twice per year. Bi-weekly is every other week. Every other week. 26 times per year versus semi-monthly, which is what I was thinking about earlier. Semi-monthly is 24 times per year. These are not the same. Clearly, they're not the same. Semi-monthly, so we're going to talk primarily about getting paid and paying bills. Many people get paid bi-weekly. This is like every other Friday. Semi-monthly, generally this means you get paid the 15th and the 30th, or they call it the last working day of the month. So if the last working day of the month is Friday the 28th, or Friday, you know, like if it's 30 days in a month. So if it is like April, then you would, and that was Friday the 28th. Sunday would be the 30th, so you would get paid on Friday the 28th. And then monthly, which is once a month, which is 12 times per year. We're going to really focus on monthly. When you pay bills, your car payment, your credit card payment, your mortgage payment, your rent, whatever, is generally going to be monthly. Many people get paid bi-weekly, semi-monthly, or monthly. So for me, I get paid monthly. Some people get paid semi-monthly. You should ask your parents, your siblings, whatever, how they get paid. You'll find that it's a mix of the three. We're going to talk about compound interest, and Albert Einstein, mathematical genius, has a fantastic quote about compound interest. Oh, you can't see that. And Albert Einstein says, compound interest is the eighth wonder of the world. He who understands it earns it. He who doesn't pays it. You want to, compound interest is fantastic when you're investing in your 401k or your money market account or your mutual fund. But when you're paying it, when you have credit card debt, not so good. Not so good. I'll probably have a little conversation with you about this in class because I just think this is probably the most important thing you learn all year. Okay, you need to memorize. You need to memorize. A equals P, 1 plus R over N to the NT. This is the formula for compound interest, or calculating with compound interest. I just call it the ending amount. A is the ending amount. P is the principal, also known as your starting amount. 1 is 1. R is the interest rate. N is the number of times the interest is paid or accrued every year. Number of times interest is paid or accrued every year. Per year, let's say. Which is why I talked to you about all of these. Okay. T is the number of years. T is always time in years. So if we're talking about 18 months, that would be 1.5 years. 18 months would be 1.5 years. 36 months, 3 years. Okay. So here we go. Again, this is just a general overview. I want to know what's better. Not what, which. My English is really off this morning, huh? You don't know it's the morning, but it's the morning. Which is better? Is it better to have 9% quarterly? Quarterly, 4 times per year? Most investments are quarterly. Most investments are quarterly. Or 9.25% annually. Okay, we're going to plug in. So my ending amount. You know what? I didn't give you a P. Okay, use whatever you want for your starting amount because we're going to be starting with the same amount if I'm just asking you which is the better deal. So start with 1, start with 1,000, start with whatever you want. I'm just going to look at $1. Why not just look at $1? So you choose. If I'm starting an investment at 9% quarterly, I want to know if I'm going to put my money in the bank, which account gives me the better deal. Let's just say I'm putting in $1. 1 plus. In this particular problem, 9% quarterly, that's 0.09. That's what's going to trip you up is the 0.09 over. N is 4 to the 4t. Okay, let's just say that you're investing for a year. Maybe you're investing for 6 years. Maybe you're investing for 10 years, but whatever the time is, it's going to be the same for both accounts. So why don't we just say 1? So here, again, I'm just going to say I'm starting with $1. Oops, 1 plus. This is going to be 9.25 is 0.0925. That matters. That 0.25 matters. Annually is over 1. You're going to earn it once. So plug into your calculator, see what you get. They're the same. It doesn't matter. They are not the same. So I only wrote down, $1.09, but the first one is 1.09308. Now, when you're rounding with money, you always round to the nearest cent. But when I'm comparing the two, I need to look further. So this is 1.09308, the quarterly, and the annually is 1.0925. Exactly. So 9% quarterly is the better deal. You may be thinking, oh my God, that's so close. Does it matter? Sure it does. If you're investing $100,000 and you're investing for 6 years, yeah, it's really going to matter. Continuous interest. Continuous interest involves E. Continuous interest. They call it compounding continuously. A equals PE to the RT. It's another formula. It's compounding interest continuously. which doesn't really make a whole lot of sense. Do we really compound continuously? No, but this is going to matter when you're doing like bacteria and things like that. But you should know the formula for compound interest. Okay, so again, you'll be asked to compare, but as long as you know how to do the previous problem, compounding continuously is the same. So for example, what if I ask you that I have $1,400 and I'm investing at a rate of 7% compounded continuously. As soon as you see the word continuously, A equals PE to the RT. As soon as you see continuously, it doesn't matter the time period. The time period doesn't matter. Is that quarterly? Is it monthly? No, it's continuous. I want to know how much money I'm going to have after 3 years. P is principal, R is rate, T is time. Time in years. Remember, T is time in years. So don't be tripped up when it says 18 months. This is a straight plug and chug. A equals P, 1400, E, R is 0.07 times 3. The E to the X key, the E to the X key is above ln. Oh, it's hard to see. There it is. E to the X is above the ln. So I'm going to do 1400 second ln, and there's my E, 0.07 times 3. $1,727.15. Always round appropriately. So in this case, don't ask me, what should I round to? With money, you always round to the nearest hundredth. So you're going to earn $327.15. Okay, doubling. How long to double your money? This doesn't matter if it's continuous or if it's quarterly, monthly, semi-annually, whatever. So let's just say I have, my starting amount is, let's just say my starting amount is $1,000. Let's put a dollar sign there. So if I want to double my money, that means my A should be 2,000. How much I want to end up with. Your ending amount, I think it's, yeah, that's how I always look at it, is the ending amount. So if I want to double, if I start with 1,000, that means I want 2,000. So that means if I start with, how about 5,000, that means I want my A to be 10,000. Commas, 10,000 or more, use commas. Okay, so this is P. A is 2 times P. Whatever your P is, if I want to double it, it's 2P. So let's just say I wanted to figure out how, that I have an interest rate of 7%. Let's just go back. I have 1,400. And the interest rate is 7%. And it's going to be compounded continuously. So I'm just using the previous problem. But instead of asking how much am I going to have after 3 years, this time I want to know how long to double my money. Okay, so that means I want my A to be $2,800. It means I want my A to be 2,800. 2, doubling my money. E to the R, which is 0.07, and then I don't know T. Okay, so if you want to fast forward it, fine. I will show you how I got the 2. I want $2,800 because I'm starting with 1,400. I'm starting with 1,400. I want 2,800. What happens when you divide both sides by 1,400? You get 2 every single time. When you want to double your money, it's going to equal 2 every single time. Okay, so how do I solve 2 equals e to the 0.07t? Well, guess what? You need to use logs. So I'm going to change 2 equals e to the 0.07t to log form. And I'm going to use natural logs because the base is e. I'm going to use natural logs because the base is e. So changing forms. This is the natural log base e of 2 equals 0.07t. Divide by 0.07, see what you get. 9.9 years. That is a long time to double your money. That's a very long time to double your money. Let's do something similar. Okay. Let's say it's not continuous. So let's stick with $1,400. Let's stick with a 7% interest rate, which, by the way, you will never get a 7% interest rate in investments. You will pay 7% when you're trying to get a car loan. You will pay 7% if you're lucky on credit cards, but you will never earn 7%. This is how banks make money. This is how banks make money. They'll pay you, like I think the interest rate right now is legitimately, I think the interest rate right now on a basic savings account is 0.01%, which is 0.00, how many more zeros? This is the interest rate banks are paying out, but they're charging 7% for a car loan. They're charging 12.99% on a credit card. That's how they stay afloat. And you can ask me questions about this in class. It's fascinating to me. Okay, let's go back. So we have $1,400, 7%, and this time, let's say that your interest is compounded quarterly. And I want to know how long is it going to take. So instead of continuous, it's quarterly. And of course, this formula is much more intense. So again, it's going to be 2 because I want to double my money. Okay, so 2 equals 1 plus R, which is 0.07, over N, which is quarterly, that's 4, to the N, which is 4T. You never have to memorize extra formulas. Those of you who know me know that I am so anti-memorizing, but I will tell you that this formula right here, you really need to memorize this. Okay, you need to memorize this formula. And then of course, you need to know, I don't think this one's so bad. Of course, you need to know PE to the RT. PERT, it's often called. It's often called PERT. Okay, so what I just did was I plugged in what happened to the P and the A. If P is 1,400 and A is 2,800, and you divide, you're always going to get 2. And if I wanted to triple my money, it would be 3. If I wanted to half my money, which makes no sense, it would be 0.5. But when we talk about half-life, it's going to be 0.5. Okay, you need to use the store key in your calculator. So I'm going to have 1 plus 0.07 divided by 4. Oh, actually, we don't really need to store it. It's a nice number. This is 2 equals 1.10175 to the 4t. Many times that's not such a nice number. I'm going to use logs. I can't use natural logs. I can't use natural logs because the base is an e. So this is the log base 1.0175 of 2 equals 4t. Okay, so I'm going to do alpha window, number 5. So the base is 1.0175. You can always use change of base of 2. This number, I'm just going to leave in my calculator. And then to solve, divide by 4. So the number in my calculator divided by 4 is almost 10 years. So this is, instead of 9.9 years, this is actually 10.0 years. It actually takes longer. You round this properly, you would get 10.0 years. Okay, this is the basic overview. Oh, I'm sorry, there's one more thing. So if you're like, oh my God, all these logs, et cetera, there is a formula for working backwards. And if formulas are your thing, great, go for it. I don't memorize any extra formulas that I don't have to. But there is a formula where you don't have to work backwards with the logs. I'm gonna turn my paper sideways. It is on page 319. And this is P equals A 1 plus R over N to the negative NT. Okay, so this again, general overview. The problems I'm assigning are really just plug and chug, practice with the calculator.